Welcome to the LV HTTP server overview. This is a project I've been working on to create an extensible and highly flexible alternative to LabVIEW's web services by LabVIEW for LabVIEW, meaning that it is completely written in pure LabVIEW to be embedded in LabVIEW applications. So for the feature overview, some of the key snippets is it uses the other libraries I've developed that abstract out the connection management and low-level data streaming that's needed for a web server. And those are libraries that are already available in VIPM. There's just been some updates and tweaks I've made to make them behave better with something like an HTTP server. It utilizes interfaces for extensibility, so you can have your own concrete implementations of those that don't have to follow a strict inheritance hierarchy, as if this library utilized abstract base classes. And it can be used from everything from basic file serving to a full application complete with authentication and security controls, and per resource security upgrades to WebSocket, connection streams. This is meant to run the full gamut for a LabVIEW-based web server. It is designed based on more modern web frameworks, so I have been doing some development with the Symfony framework in PHP, and it has this really neat event subscriptions setup where you can plug in additional code to be run at specific spots during request handling. I follow that same model here. In this library, it aims to simplify common operations, such as there is a specific response class, file response, where you just give it a path, and then when it's time to send that data to the client in the response, it'll open the file, read out the file, and stream that to the client without you having to do that yourself. Additionally, there are utilities for reading query parameters, and the request is parsed for you. So all of that is done and is pretty easy. However, if you want access all the way to the underlying TCP connection, you can get that. And then it is built with debugging and performance logging included from the start, which is very crucial for testing the performance of your server code and figuring out how well everything's working. So this is the request processing flow that it uses, and right after this, we'll take a look at some code, but there are these 8 kind of stages to potential stages. Not all of them have to run for every request for how a request gets processed. And you can do everything from close the connection before the request is even read and parsed. Then it will then read the request from the client connection, parse it, create a request object for you. You can then have the pluggable code to do some initial processing of that request. The next step is the routing, which is where ideally you would pick which controller you want to run your code. So a controller would be analogous to a web resource VI in a web service. Controller is going to be the main lifter for taking the request and generating a response for that request. But before the controller is run, there's a step to make sure everything is finally initialized for the controller once the controller has been selected. Then, as I said, the controller's job is to generate a response. So then after the controller runs, there is a hook for providing additional processing for responses. This can be used to apply global headers, such as CORS headers. And if you need to do any response validation, like if your controller produced a file response, does that file actually exist? And if it doesn't, raise an error 7, which can then be picked up by the exception handling. And then the last step of the normal flow is the cleanup, where if you, during your execution, resources were created or there's some of your own debugging and logging that you want to do, this is the last step after everything has been sent and it's just getting ready to close down. If at any point during any of these steps an error is returned from a handler implementation, Everything following that will be shortcutted, and it will then begin the exception handling process where it'll iterate over any registered exception handlers, and they have the option of producing their own response to send to the client, such as if you need to send a 404 file not found error, and if nothing else catches and handles the exception, we produce a 500 internal server error response that can get sent to the clients. So let's go ahead and take a look at what this looks like in practice. So here I've got my project. Here is the server code, the main actual server class. There are a handful of interfaces that define the basic structure of controllers, handlers, services aren't implemented yet. They'll be coming down the road. And then there's specific handlers for those pluggable steps that you can provide additional functionality for. The server is pretty simple in its public API. Initialize it, start the server, stop the server, clean up everything when you're done. Routines for adding handlers for those various steps, registering controllers that are available for being run, and then there's going to be some reporting and logging data types available. So using it can be pretty simple. Let's just say I want to throw up a single page, respond to a single request. This is the whole top level code for running the web server. So here's that web server's constructor. It does have an optional debug flag. We're not doing anything that could really need debugging in this one, so I don't have it set. And then you're going to go through and configure the web server. So this would be adding controllers, adding handlers, and maybe there will be some other configuration steps that get added in the future, such as when services are implemented. But here we've just got this simple test index controller that we're telling the web server we want to make this as an available resource for requests. And then you start it, and then you wait, tell it to close and clean up, and we're done. So this is a controller. This is a class that implements the controller or inherits from the controller interface. And it's mainly identified with regular expressions. So this is one where as long as we're at the root of a request, so the caret at the start of a regex means lock it to the beginning of the line. And then we're going to look for a word in one part of the path and optionally have a number supplied as another path segment. And then there is built-in functionality. There are built-in handlers in this long name built into the server library for doing things like turning these regular expression grouped segments into arguments that can be available for the controller. So then in the actual controller, we can generate some HTML content in this case. And we can see here, this is just doing a simple format into string. We've got a numeric specifier and a string specifier where we read those regular expression arguments out by their index. This is an abstract mapping. So most of the time it would be names, but for these regular expressions, it's just the numeric version of the index that their regular expression would match with. And so we're just sending a generic response, setting the OK status code, setting the payload, which will be this HTML page. And I can go ahead and run this. Up. Get all sorts of fun news headlines. And example that I posted to Twitter looked like this. So I'd like to have 3 tacos. And we can see this matches. Oop, I didn't want to come back everything. This matches what was generated here. And we can go into the networking tab, and if I let's say I want some puppies. See, it's making this always shows the final segment of the URL, but we're making the request to /puppy/3. And what did I break? But you'll be able to see all of the request information that's going through here. And of course, during the demo, something broke. Why wouldn't it? At least it does close down cleanly. So the next example, if we wanted to do basic file serving, we've got this application, and we'll show off one of the debugging features that's available and built in. So this time we've got this controller. This controller is one of the built-in ones. And so its regex is actually going to be empty. It's not set, which means it will match any path that's specified. And that may be something that you want multiple controllers to do, depending on some various variables and aspects of the request. So the other thing that all handlers and controllers can specify is a priority. So this is a U16, so this is set to mid-range, but a pretty high value. Any lower numeric value has a higher priority. They're just sorted in increasing order because they're all just shoved into a map. So you could have some other controllers running with regexes that attempt to match path segments, and then have a fallback controller like this that'll match anything that hasn't been matched yet. And you, in that case, we have it look at the path that came in as part of the request and resolve that to a local file and generate a file response. And then there is additional built-in functionality for ensuring that it's a valid path. It'll automatically return a 404 error. Notice that we did not actually return any errors out of here. And we don't want to try to open a file that doesn't exist, or maybe there's some protected files, like if you're familiar with the Apache web server, it's got its .htaccess files, where per folder you can specify additional directives for how the web server operates on the files in that folder. And yeah, so you could have additional steps. That's what some of the response handlers and things could see. Hey, is this a file response? Is this trying to serve a file that shouldn't be servable? And it could, replace that with a unauthorized or a 404. But pretty straightforward, pretty simple to get some of these basic features implemented and configured with a server. And if we run this one and I make a request, I'm gonna type in some garbage. Did I get a firewall activated or something? Try this from a different browser. Other browser outside that. Yes, this is responding instantly, so I don't know what Internet Explorer is doing. But Chrome is working just fine. And we can see I tried to access a file that doesn't exist, and because I have debugging enabled, it actually sent me back the error message code and the message string. So now if I hit refresh traces, we'll see that failed connection from Internet Explorer. I'll have to look at that, or sorry, Edge. And then here we can see the next request I made. It's this one actually. So this is the one that did finally succeed. It looked like Edge had created an initial connection for some reason that it didn't actually send the request through. And right now I've got it set so I can debug. So until one request finishes, it won't handle a second request. So that's what was blocking. But here's the one that went through for Chrome. And here we can see the individual steps that happened. So it initialized the request object. So this will happen after it parses the request. Here's the target resource that was selected. Here is the client that's making the request. How much time it took in total from when the request was finished reading, because it turns out that Chrome will open connections prematurely so it can make requests as soon as it needs to. But yeah, so we could see the different steps it could handle, the class name of those. So here's one that's the built-in router that just uses that regular expression to match up a controller. It identified the standard file serve controller. Here's the handler that takes path parameters, if there are any that are part of regexes on the URL path segments, and turns them into arguments. And run the actual controller. It generated a file response. But then after that, the file existence checker ran, and instead of letting it pass, it returned an error. So notice that even though the controller tried to return a file response, what actually got sent back was a regular response with a 404 code. And then there's an exception handler class, which takes the errors, identifies the error 7 that this guy generated, and generates the response that's actually sent to the client. And so if I stop this, turn off debugging, and run this, and then try and access this page again, this time we just get the built-in browser reporting of the 404 error because we didn't actually send any content back. And then for the last demo is showing off a very insecure way of testing for authentication. So this time we are registering a controller, and this controller will actually be able to serve multiple pages, and we're adding a request handler. Do some checks of the request once it's been parsed and initialized. And there isn't anything else being done in this top level application. Everything is configured by these concrete implementations that get registered with the server. For the first handler, we've got this handle request dynamic dispatch VI that'll get called. And this does some things like there are some paths that we want to let through without doing any kind of authentication check. So we'll skip looking for if those are the resources that were requested. And if it's not one of those, then we'll look in the URL for some query parameters, see if there was a user and a pass returned, and if they match these values, these super secure username and passwords, and this super secure plain text matching of everything. Don't do this in real life. This is just demonstrating the capability. And if it doesn't match, so if there is a mismatch in the authorization, we can generate a redirect response, and we'll redirect the browser to the /noauth resource. This is a common technique for authentication and authorization components in modern web frameworks. There'll be some step that runs that says, I don't know who this is, or they're not allowed, and then redirect them to another page. Normally it'd be a login page. I don't have a login system implemented yet, so this is just a page telling them to add this information to the URL and try again. And then if it does succeed, there's this arguments container class that's set up, and we can create a user variable in there and pass in the username that was passed in as the query parameter. Since this only allows one user, it's not surprising what will be generated later on, but if this was actually looking things up in a database or a file somewhere, this would be a lot more flexible. And then to make sure we're not shortcutting to sending an early response, this is just a constant for the generic response class with nothing configured on it. And that'll allow it to continue to follow the normal flow. Same thing's done here. If it's one of these special identified paths, we don't want to send an early response, so we'll keep processing the request. And then in the actual request handler, oh no, that's expand this. So this controller will match everything. And then in its request, it'll look at what path is being sent. If it's that fave icon that browsers try to grab to provide the icon in the tab, we're going to just let it know that we don't have that. If it's that no auth page, we're going to send it some static content that I've just got saved here as a string. And then for any other resource, we'll just tell them what they arrived at and what name it is. So we've got three format specifiers in here, and they're all strings. So these two strings are just going to be the username, so the title, and then a welcome message at the top. And then in italics, we're going to put what the path was that they were requesting. So when we run this one, and we'll pick that one. So this is that no auth page. We can see the browser bar is changed to no auth. And this is telling you to add the information to the end of the URL you were trying to get to. If we look at this trace log, I click refresh, we can see the initial request doesn't exist, resulted in a 307 status and a redirect response, which told it to go to no auth. And we can see the steps. Of main interest here is that once that initial request handler ran and provided a response, we didn't run most of the other steps that are available in this server. And then once it makes the request to no auth, that one does get passed. Here we can see it's not generating a custom response, so we don't handle it. We don't shortcut the rest of the handling. And then we'll go through the routing handlers, the controller initialization, run the controller. It generated a response because we were just sending back HTML content. Do the common check for if we were returning a file, and then send the response and do cleanup. So now if I put those parameters at the end of a page, it'll let us through, and we get the username. It's also appearing in the title for the tab and the resource that was requested. And now when we refresh and look at this last trace, looks almost identical to the no auth request. The same exact flow happened. This our controller is returning different content. So we talked about server configuration. It's as simple as running a bunch of registrations at the beginning of the application after you've done the initial, called the initial constructor method of the server. You are then free to add handlers and controllers to it, and be more features in the future. Those handlers can themselves have some configuration. For instance, with the standard file serve controller, you can tell it what the root folder is that contains your resources. And then any requests would be, made relative to this starting path. And then, in the future, there will be utilities built in for authorization and security. So we looked at the tracing and logs. Won't look at these again. The difference of that debugging flag. So if I go back a couple of slides again, we've got this debug flag that is available when you're initializing the server instance. And the difference that we demonstrated was if debugging is enabled, this is useful for debugging in a development environment. Stuff like this should not ever be turned on in production because it exposes paths and folder layouts and any other information that might show up in a LabVIEW error, which LabVIEW error sometimes can be helpful and provide lots of details, sometimes not so much. But when it is super helpful, you don't want to expose that to anybody trying to use the website. So, for normal ones, you can either generate just a generic 404 page with your own styling and everything, or just let the browser show them that it was a 404 status. So we briefly looked at the how arguments can be handled. So there is this arguments class that's in there right now, and this is just a generic map to variants. It actually uses the map from LabVIEW that exists now. You can access things by string identifiers and store any kind in. The thing that reads arguments is a vim, so you can pass in a data type and it'll do the coercion for you. In the future, as this holds more types of objects like services, you'll be able to read them out directly as well. And the plan for things like services is services are going to be more or less globally accessible functionality or data repository, but things like database functionality, authorization functionality, logging, that could be accessible throughout an entire request processing flow, that aren't just things generated as a result of that specific request. These would be accessible to all requests to use if they needed. So yeah, that's the overview of this feature. I'm really curious to hear what anybody's feedback might be and what questions they have about it. Again, this is meant to be somewhat of an alternative for web services with more flexibility for people that do want to do user authentications easier and do dynamic or like static file content serving, but with the ability to update those files on disk while the web server is running and see those changes reflected when they're returned to clients, which is something you can't do with web services. So yeah, this is all up on GitHub, what we just looked at here. I pushed just before this, so you could take a look at the code. Right now it does rely on some of my other libraries that have not been updated in VIPM just yet. But I'm curious, what questions do y'all have about the usability? Was there anything that's maybe confusing about how it's supposed to be used and how you would implement some of the functionality? Things that can help me either implement better features, better documentation, or maybe this is really interesting and you'd like to help me out, and I'd love to hear from you just as much. So thanks for stopping in, and happy lab viewing.